Okay, let's take a look at a third problem here for our virtual review. This one deals with volume, which was, of course, one of the chapters we studied. It says that grain silos are commonly built in the form of a right circular cylinder topped with a hemisphere. See the drawing. I guess it's actually below, not at right. If the interior of the silo has a diameter of 30 feet, a height of 90 feet, how many bushels of grain is it capable of holding when it's completely full? A bushel is equal to about 1.24 cubic feet. Okay, let's go ahead and zoom out so we can go ahead and see it. All right, away we go. So I guess the point here is to go ahead and find the volume in cubic feet and then convert it into bushels. So here we go. Let's go ahead and talk about what the volume of this particular grain silo would be. So the volume is going to be comprised of two components. We can see that there's going to be the volume of the cylindrical portion and the volume of the sphere added in. And right away you should notice that the volume of the cylindrical portion is going to be much greater than the volume of the sphere because, of course, it seems like it's more voluminous. There should be very little of the volume comprised in the sphere. So here we go. We'll go ahead and draw, or I guess start thinking about how we're going to calculate this. So if we want to know just the volume of the cylinder, we know that the volume of the cylinder is equal to big B times H, where big B would be the area of the base. So this would be our big B. And the volume of the, hemispherical part, this up on top, would be half the volume of a sphere itself. So that would be 4/3 pi r cubed, we know. So half of that sphere's volume. Okay, so let's see. The big B here that I'm after, of course, is a circle, and its area is pi r squared. So pi r squared h, half of 4/3, of course, is going to be 2/3 pi r cubed. So this would be the formulaic version of the volume that we're trying to find. Let's go ahead and now plug in the numerical constants that we know should go here in for these variables. Let's go ahead and talk about what the radius of the cylinder is. If I look at the cylinder, we're told that the diameter is 30 feet. That means its radius is 15 feet, so 15 squared. Now this is where it gets a little bit tricky. 90 feet is given as the height of the whole silo. That isn't the height actually of just this piece, which is the cylinder. It's actually kind of cut into two here, and we know that if the radius here is 15, then the radius here would also be 15, and that means that if it's a hemisphere, that radius is constant everywhere. So this would be also 15 feet in the hemisphere. So if I want to know the height of just cylinder, then I'd have to take 15 away from 90, the height of the whole thing, and that would give me 75. Okay, so the height of the cylinder is 75 plus 2/3 pi. The radius of the hemisphere then is going to be 15. And now we'll have to do a little bit of arithmetic. I'm going to get the calculator out and go ahead and calculate this. So it's pi times 15 squared times 75 plus 2/3 times pi times 15 to the third. I'm getting 6,082.95, so I'll say it's 60,000, 82, we'll call it 0.96 cubic feet, of course, because we are in feet everywhere. And now how do we convert that into bushels? So 1 bushel is equal to 1.24 cubic feet, so the volume in bushels will be 6,082.96 cubic feet times the number of bushels for this 1.2 cubic feet in a single bushel. So I guess I'll put 1 bushel times over 1.24 cubic feet. And keeping in mind that we're just multiplying by a constant here, 1 bushel is 1.24 cubic feet, so this is just a 1 really. So I'll take this number and divide by 1.24, and I'll get a number out of 48,453, 1.99. So we're going to say it's roughly 48,454 bushels.